Profiling Kafka applications can be tricky. Today I'll show you how JProfiler makes it easy. We're looking at a simple Kafka demo application with 3 topics: sensor data, production events, and maintenance orders. Sensor data and production events are simulated by a Spring scheduler every 500 milliseconds with random data. The consumer for sensor data messages issues maintenance order messages when the temperature of the sensor gets too high. As typical for Spring Kafka applications, the messages are JSON messages, and here they are serialized as strings. Let's use JProfiler and check out what it can do for us with respect to Kafka. The IDE integration makes this very easy. The Kafka probes are in the HTTP, RPC, and JEE probe settings category. We can change their configuration before starting the profiling session. There are separate probes for Kafka producers and Kafka consumers with separate configuration options. By default, JProfiler does not record any data on startup. Here I have configured a recording profile that records CPU data and both Kafka producer and consumer probes. Profiling settings are remembered on a per project basis when profiling from an IDE integration, so my last settings are still in place. No need to adjust call tree filters. The IDE integration automatically includes your project's packages. Let's get started. The VM telemetries show low-level measurements by default, but you can add high-level measurements from probes as well, like the number of Kafka events that are produced. Let's do that. Before we dive into probe views, let's take a look at the call tree to get a sense of the overall activity. There are 3 top-level nodes in the call tree. One relates to the startup, one shows the message producers, and one shows the message consumers. We can see that messages are continuously being produced and consumed. Now let's stop the current recording so we work with a fixed dataset. What makes JProfiler unique is how it blends low-level data with domain-specific probes. You'll see that clearly in the call tree and the Kafka probe views. For the consumers, the call tree is split for each topic. The splitting is configurable and will be explained in a future screencast. So you can see the call tree for each topic separately. These splitting nodes are present in the backtraces for CPU hotspots as well. In this way, you can measure how much different topics contribute to the hotspots. For the producers, we get hyperlinks into the probe view to see data on the Kafka messages. Let's click on that link to take us into the Kafka producer probe view. We land on the call tree view of the probe. It shows a call tree with message nodes as the leaf nodes. By default, this is the topic name, but just like for call tree splitting, this is configurable and can rely on data from the message value. For many use cases, the probe hotspots view helps you analyze performance characteristics and identify problem areas. Opening the hotspots will show you the reverse stack traces that contribute to the hotspot node. For debugging, single events are available. They're not recorded by default, but you can switch on recording at any time while the probe is being recorded. Event data includes the description, the thread, the partition, and key value sizes. Also, events and errors are differentiated and can be filtered. The filtering capabilities of the probe events view help you find events of interest. At the bottom, the stack trace is shown for the selected event. Selecting multiple events shows cumulated information. For the consumers, the call tree is fairly simple because all messages are handled by the Spring Kafka listener. Consumers provide timing information that's best explored in the hotspots view. The telemetries also include an average listener execution time telemetry. And the events view includes a duration histogram where you can easily spot and select outliers. And that's how JProfiler gives you deep insights into Kafka applications, from message flow to performance hotspots, all in one integrated profiling session.